Today we're going to talk about logarithmic function. What's a logarithmic function? First, let's look at the notation. Say f of x equals log x base a. This is the format for a log function. The input x is the variable and the base a is a constant value. Similar to the exponential, that a is a positive number and we assume not equal to 1. Because what we want to talk about today is basically an inverse of an exponential. Last time we discussed an exponential a to the power x. If you have a function f of x as a to the power x, this was an exponential form of a function. For example, if you have 2 to the power x, so here let me highlight this part. If you have 2 to the power x and you pick an input like 3 and say, what is the output? If you replace x with 3, 2 to the power 3 becomes 8. The question becomes, what if I give you 8 and say, what is the original x values? And say 2 to the power x equals to 8. Can you tell me what is that x value? So if you have the equation y equals to 2 to the power x and tell you y is 8, my question becomes, what is that x value that gives us y equal to 8? And this is basically the operation the log does. Log takes 8 as an input and gives you that x value as the exponent. So when they say log 8 base 2, means we're looking for that specific exponent that 2 to the power what number becomes 8. So log and exponential are inverses of each other. A always represents that base. And the base is a positive number not equal to 1, just to avoid having constant function. So here there's a relation between log and exponential. If you have a log function y equal to log x base a, similar to if you have log 8 base 2 equal to 3, then what you can say is 2 to the power 3 must be equal to 8. That means a to the power y must equal to x. This is the relation. Sometimes I write it in terms of boxes and say log, let's say you're given a number, 8 base 2, and you want to figure out what that is. I write it as 2 to that power equals to 8. This is easier to see. So you can always write this box and say, okay, figure out what is this number. Simply it is 3, therefore log 8 base 2 is 3. We're going to do a bunch of examples. But the definition is important that log is an inverse operation for the exponential. And if a to the power x is an exponential, then the inverse would be log x base a. There is one property that you should notice. Whenever you replace a number into the exponential, it could be 3, it could be negative 3. What you get as an outcome is 2 to the power negative 3, it's 1 over 8. The outcome here, this y values, are always positive number. You can never get 0, you can never have a negative number. If you remember, the curve for the exponential was always above the x-axis. It means that all the y values were positive. Now, this 8 and 1 over 8 are the inputs for the log, which means the domain of log function must always be a positive number. So the domain is always numbers above 0, not even 0. So the domain for the log exponential, the log function, is always 0 to positive infinity. Unless there is a shift inside that we deal with. So if you have log x base a, simply the domain, the inputs to the log must be always a positive value. That's what we would use later on to figure out the domain. Okay, so let's do calculation. Let's do a bunch of examples. Let me change the color here. Let's try a simple one, log 9 base 3. Ask yourself, what am I looking for? You can always convert between exponential and log. It's not easy to see through the log, but if you convert it to exponential, that means 3 to what power equal to 9. If I can answer this question, it's the same as answering the other one. So 3 to the power 2 equals to 9, so log 9 base 3 must be 2. Okay. After a while, you don't need this conversion, but it's very useful when we solve equations later on. You will use this as well. Log, let's say, 1 base 3. Now, this is not easy to see, but if you write it as exponential, 3 to what power equal to 1? This is always the base. This number here doesn't really matter if it's 3, 2, whatever. This, let me show you. This is 3. If it's a base for log, it's going to be a base for the exponential. 3 to what power gives you 1? I hope you know that. 3 to the power 0 equals to 1. So log 1 base 3 is 0. How about log 1/2 base 2? You can always write it again. 2 to the power what gives you 1/2? If you remember negative exponent, 2 to the power -1. So therefore log 1/2 base 2 equals -1. How about log 0 base 3? 3 to what power gives us 0? 3 to the power 0? Not really. 3 to the power 0 is 1, as we mentioned here. 3 to the power -1, it's 1/3. 3 to the power -2 is 1/3 squared, which is 9. 3 to any number is always a positive value. So you would never have 0. This never happens. So there is no solution, undefined. And this is one of the reasons that we discussed the domain. The input here is 0. But we said the domain of log function should be any number above 0, not even negative number. So if you had log, for example, if you had a log -3 base 3, and you write 3 to what power gives me -3, there is no number to fill in this box. It's not possible to pick any number, so this is undefined. There is no x value that 3 to that power gives you -3. 3 to the power -1, if you say -1, that is incorrect because that is 1/3. So there is no y value. It's not possible to replace a negative number. You can think about the square root. But for square root, there is complex values. Here, we don't have any complex results either. It's undefined value. Okay, let's maybe try a couple more. Log 0.1 base 10. Maybe not that easy to see, but 10 to what power gives you 0.1? You can write 0.1 as 1/10. Maybe it's easier to see now. 10 to the power -1. Yes, -1 would be the answer. You can try fraction as well. Log square root of 2 base 2. Means 2 to what power equals square root of 2? If you remember, fractional exponent to the power 1/2. Therefore, root 2 base 2 equals 1/2. Log 5 base 5. This is one of the easiest one. 5 to what power equals 5? Simply 1. Therefore 1. Okay. I think this is good enough. In all these examples, I picked the base to be a constant value, positive, greater than 1. But it is possible that the base is smaller than 1 as well. Something like log 1/2, I don't know, 4. You want to figure out that number? It's not that easy to see now. You have to go through the process and say 4 to what power equals 1/2. Sorry, 1/2 to what power equal to 4. I wrote it in the wrong order. Don't make the same mistake. Okay. 1/2 to what power equal to 4. So now, what is that exponent? If you say, I picked 2 here, what do you get? 1/2 squared would be 1/4. But if I make it -2, then 1/2 to the power -2, it's going to flip the fraction. So it's going to become positive 4, -2. Just wanted to show you that it's possible to have fraction as the base as well. Since we had 1/2 to the power x as an exponential, possible to have a number between 0 and 1 as well. But you can never have a negative base. Okay. Maybe We try to calculate some of these values if we want to graph functions, but there's a shortcut to graphing. I want to use that shortcut to graph X logarithmic function. Here is the important thing that we have discussed already. If we wanted to talk about the inverse function, we needed the function to be a one-to-one function. So in this case, it had to pass the horizontal line test. If you had a to the power x as the function f of x, the graph would be one of these two shapes. This red lines, that would be the graph of the a to the power x, one of these two. If the base was greater than 1, this left one would be the graph. If the base was greater than 1, then the right hand, between 0 and 1, then the right graph is the graph corresponding to the exponential a to the power x. Is the one-to-one function? In both cases, they pass the horizontal line. So this is a one-to-one function. That's why we can discuss the inverse and say, what is the inverse? The inverse is the operation that we defined as log x base a. So log x base a and a to the power x, these are inverses of each other. And if you remember the relation for the graphing, if you have the graph of a to the x, the graph of log x base a would be just a reflection. And the reflection would be about the 45-degree angle line. So I'm going to draw the curve for log x base a. If the base is greater than 1, this is how the graph looks like. This green curve. If I didn't draw that nice, but you'll see. Here we go. That looks better. This point is at 1. It's a reflection here. 0 and 1 becomes 1 and 0. On the other side, the other graph reflected will look like this. Something like that. So what you have is, if you had an increasing exponential, you still have an increasing logarithmic. If you had a decreasing log, then the graph is still decreasing. But what has changed is, remember the horizontal asymptote now has become a vertical asymptote. This y-axis, the green curve is approaching that y-axis in both cases. So for logarithmic function, what we have instead of horizontal asymptote is a vertical asymptote. What is that vertical asymptote? In this case, it's simply the y-axis. And y-axis is a vertical line x equal to 0. So if you have a vertical asymptote, if you have a log function, there should be a vertical asymptote. If you have an exponential, there should be a horizontal asymptote. And there you can involve shift left and right, up and down, multiplying by negative numbers just to rescale it. But if you have this, to transform it. But if you have the structure of the graph, you can do those processes. We'll do an example just so you can see here. For example, let's try to graph y equals negative log x plus 1 base 2. How about that? This is a fairly simple question. You can do it in stages. First, if you have log x base 2, so first graph log x base 2. This is what we try to do. Then through the transformation, what would be the next step? Step 1. Step 2 would be dealing with this x plus 1. If you make a change inside the log function, it's going to be a change in the horizontal direction. So you'll have a horizontal shift, the transformation. How many unit? 1 unit. Which direction? Always, if you make a change in the x direction, is always in the opposite. 1 unit left. Okay. Then deal with this negative outside finally. You've created the log x plus 1 base 2 already. Multiply by a negative. This would be a reflection. Reflection about what? The y values are getting multiplied by a negative number. So if the y values are reflecting, it means you're reflecting about the x axis.